Hi everyone, I'm recording this video for ASEE 2021 and I'm presenting this paper, Computational Thinking, a pedagogical approach developed to prepare students for the area of artificial intelligence. And my name is Yang Sang, and I'm the second author of this paper. And as you can see all the information, the names of the authors and our email addresses. Okay, so let's start from talking about the computational thinking. And for the computational thinking, and there are multiple definitions, and this is the definition I love the most. Well, it is the thought process involved in formulating a problem and expressing its solution in such way that the information processor, both human or machine, can efficiently carry out that solution. Well, the reason that I love this concept, the definition the best, is it puts the human and the machine in parallel. And when we are trying to formulate a solution to a problem, and we want to define that so that people, the human, can understand that, and at the same time the solution can be processed using a computer. And well, we are really putting the human and the machine in parallel, because when we are developing solution, well, it has to be understandable and executable by both human and the machine. Okay, and then the researchers believe that the students who have been exposed to the computational thinking concepts will be more successful in the ever evolving global society. And well, if you want to do a little bit more research, and you will find that the computational thinking is taught well from K-12 to all the way up to the college level. And well, in the computational thinking, there are four key components, and they are decomposition, pattern recognition, abstraction, and algorithm. And when we want to develop a material to teach computational thinking, and we are using the sequence of decomposition and then pattern recognition and abstraction and eventually algorithm. And well, this is my personal feeling that if I'm teaching the computational thinking, I want to teach those four concepts in that sequence, and from the easiest, the most obvious one, and then to the harder one. And the hardest one, I would say, should be the algorithm. Okay, and what we have done in this paper is we developed a course module for an LMS, and we are using Canvas in our university. So we developed a module for Canvas, and in our module for Canvas, there are a total of 6 pages and plus 4 quizzes. So for the 6 pages, we have an introduction page, and then we also have a conclusion page. And then remember, there are 4 key components in computational thinking, and for each of the key components or a key topic, we develop 1 page and then 1 quiz. So 4 pages for those 4 key components, and then 4 quizzes followed to each of those components. Okay, and then well, and this for this Canvas course module, it is designed to be doable in 1 week as a reading assignment. So well, students can just read all the content and the pages and then do the quizzes. And well, this the reason we designed this way is we want to make this course module open to everyone. And if you are teaching a STEM course, for example, chemistry, and then you feel that you want to have a little bit component of computational thinking, but you don't really want to allocate a full week talking about computational thinking, and here is another choice. And you can just use our course module and import that into your course on Canvas if you are using Canvas, and then you can just give that as a reading assignment. And then well, we have if you are interested, and we have a the Canvas dump file, and then with and together with the instruction on this link. So if you want to pause the video and find this hyperlink, and it will bring you to a Google Drive folder, and you can find 1, the dump file of the Canvas module, and 2, an instruction file. Okay, and then well, I am well on this page. I'm about to show you some of the screenshots, but I decided I want to show you the real system. So let me stop, and then let me go to my browser. Okay, so well, I'm about to show you my design and analysis of algorithm course, and if I scroll down, and you will see there is a component or a module called computational thinking reading assignment, and this is actually a reading assignment that I give to my students. And well, by the way, if you want to import our Canvas module, and you will have exactly the same module imported into your Canvas course. So you can see we have a computational thinking. This is introduction page, and then decomposition quiz, Python recognition quiz, etc. And eventually we will have a final page. Okay, so if you want to go into the first one, and this gives the high level information about the computational thinking, and then there are hyperlinks into each of the components. So if we want to go to the decomposition, we can go here, and this will bring you to the decomposition page, and it will explain to you what does the decomposition mean. And then we move on, and there is a small video talking about the concept of decomposition. And if we move on, and we want to give you a few more examples, a complicated STEM example, and plus some of the everyday examples. And eventually, and there's a icon here. If you click on this, and you will go, it will bring you to the corresponding quiz of the decomposition. And if I want to go back, and then let's see if I'm interested in the abstraction, and you will find something similar. We started from giving you the concept of the abstraction, and then well, we want to we have a short video showing you the idea of the abstraction again from a different perspective, and then we want to give you a STEM example, and plus some of the additional examples in other subjects. And this is one of my favorite. I'm showing that, well, no matter you are shooting a basketball or if you are firing a cannon, and actually those two concepts, and they belong to the same family of problem. And once you are able to solve one problem, you can use the idea of the abstraction so that you have a solution, not to one specific problem, but to a family of the problems. And if you understand shooting a basketball versus firing a cannon, they belong to the same family of the problems, and now you got the idea of the abstraction. Okay, so as you can see, for our course modules, and we don't really teach coding, and we just want to give students some the concept of using the computational thinking to solve their problems. Okay, so let's come back to my presentation. Okay, and in our data collect, in our experiment part or the validation part, and we give the computational thinking module to 3 classes. And the course one, well, and by the way, those courses are all in the UNC Wilmington, and we are an R2 university, and all the courses are given in the spring 2021. And the first course, that is a computer science capstone course. This is a CS1, or the introduction to computer science. And course 2, that is a special topic AI course open to both graduate students and undergraduate students. And course 2, if I remember correctly, that is a course on 400 level. And course 3, algorithm, that is course on 500 level. That's for graduate students. And for both course 2 and course 3, and you will see a mix of the graduate student and undergraduate students. The reason is that we do have a 4+1 program. That means if a student is in that 4+1 program, and they, even though they are still a junior or senior student, and they are allowed to select some of the graduate courses. Okay, and then one thing we well, and we want to well, this is the way that we design the experiment and the data collection. So we give the computational thinking module as a reading assignment to the student in all those 3 courses, and the student have limited time to finish the computational thinking module, and we give them 2 weeks, so that's plenty. And for the and there are some of the auto-gradable quiz questions like multiple select or multiple choice, and then when students submit their solutions to a quiz, and they will be able to see the results immediately. And then if they say they did some of the questions wrong, and they can retake the quiz, and we allow students up to 3 retakes for each of the quiz. Okay, and then, well, the first thing we are interested is the students' participation. And for the participation, since we are collecting the data from the Canvas system, and the participation in Canvas means the number of the clicks. Well, and then we created this bar chart, and then the x-axis, those are a total of the 10 components in our course module, including 6 pages and 4 quizzes. Okay, and then those are the x-axis, and for the y-axis, that is the total number of the participations. So the first bar is the number the introduction page, and followed by the decomposition page and decomposition quiz. So the first box, we have the decomposition, the page, the reading material, and then followed by the quiz. So a page, and then the quiz, and then another page and another quiz. Okay, as you can see, well, students tend to have more clicks on the quizzes, and of course, because well, we allow students to do the retakes. And for some of the harder quizzes, and for example, the abstraction and the algorithm, and you can see students are doing a little more retakes. So it seems that the students are making use of the number of the retakes to get all the questions correct. Well, and another thing we are interested in is the time spent on doing the quizzes. And for the x-axis, though they are the number of the minutes the students spend on the quizzes in total. And then, well, another thing we did was we say the course 1 is a group 1 because all the students are supposed to be the first year or second year of the college students. And when they are in the course 1, and it is very likely to be their first coding course in their college career. And for the group 2, we have the course 2 and course 3 because the students are in those courses are junior, senior, or graduate computer science students, and they have been doing computer science courses for some time, and they are expected to know computing more than the students in course 1. Okay, and then for the x-axis, remember that is the number of the minutes, and then for each bin or each bar, the width is 40 minutes, and for the y-axis, that is the number of the students. Okay, so well, the first thing we can see is on the right side, and there are some outliers, and I can't really imagine that a student spent, well, more than 1,000 minutes on the quiz. So it looks to me like a student click on a quiz and never finish that and leave it for a couple of hours or a couple of days, and then the window got closed eventually. Well, and for the and if we look on the left side, and for the group 1, well, the majority of the students spend 40 to 80 minutes to finish all the quizzes, and that is kind of reasonable because they are students new to computer science, and they have to do a little more reading, and they have to think for longer before they can do the quizzes correctly. And for the group 2 students, and they know computing much more than the students in group 1, so they are able to, the majority of them are able to finish in 40 minutes. So this is kind of what we expect to see. And another thing is we will also want to see the number of the views on those pages. And remember, we have a total of 6 pages. And as you well, and unfortunately, since we are using the LMS to collect the data, and the Canvas system can only give us the number of the views, but the Canvas system doesn't give us the durations of each view. So, well, we know that the student opened up that page, but we don't really know how long the student really stayed on this page. So this is one of the limits of this study. And another thing I want to remind you is, there are a total of 6 pages, and this means we expect students to open 6 pages at least, or have 6 reads on the pages at least. If the student wants to throw away the introduction and the conclusion part, and then there are still 4 pages for the 4 major topics. And let's take a look on what we have. So, for the x-axis, that is the number of the views on the pages, and the width of the bar should be 2. And then for the y-axis, that is the number of the students. So, for the blue bars, as you can see, for most of the students, they did 5 to 6 reads, and that is kind of reasonable because we do expect them to do at least 6 reads before they can finish this course module. But for the group 2, and I do see a lot of students, they did only 0 to 4 reads, and 0 to 4 reads, and this means for some of the students, they feel they're capable enough to do the quizzes even without reading the pages. So this is our observation, and it seems that the junior, senior, and the graduate students, they are confident enough about those concepts, and they can just click on the quizzes and start to work on the quiz questions. Here's the conclusion part. So, let me remind you again that the computational thinking is more than just using the technologies or computings and to write code. It is more like a mindset and for students to acquire, so that they can think like a computer when they are approaching difficult problems. It can be included in many subjects and not just in computer science courses. And if you're teaching chemistry, or if you're teaching mechanical engineering, and if you want the student to have such a mindset, and feel free to click on this hyperlink, and then you will see our Canvas module, and then you can import that into Canvas, and you can also make any changes before you push that to your students. We designed this Canvas module to be a course module as a reading assignment that can be included in many lower level STEM courses. If you have any questions about our course module, or say if you're using Moodle or some Blackboard, and you cannot directly import the Canvas, but you are interested in this course module, and shoot us an email, and we will see how we can cooperate, and we can send you the source file of our course module. Okay, so this is my presentation, and thank you for coming. Bye.